Hey everyone, in this video I'm going to share about the power requirement of a water pump. The purpose is to determine the electric power needed by the system and calculate the efficiency total of the pump. The water pump consists of three powers. They are hydraulic power, shaft power, and motor power. These power related each other, and the first thing should be determined is the hydraulic power, and it followed by shaft power and motor power. Now let's see the basic power formula. Power is equivalent to a unit of work divided by a unit of time. If we describe the unit of work, it's equivalent to a unit of force times unit of distance. And the unit of distance divided by the unit of time, it will be velocity. So the power is equivalent to a unit force times a unit of velocity. And the unit of power is the watt. Now let's see the hydraulic power formula. The hydraulic power formula is equal to density of water times flow rate times acceleration of gravity times head. The unit is kilogram per meter cubic for density of water, meter cubic per second for flow rate, and meter per second square for acceleration of gravity, and meter for head. If I eliminate the meter cubic, it will be the same unit with the power formula, with the unit in watt. To understand this formula, now we see the simple example. Let me say I want to distribute amount of water with flow rate 600 meter cubic per hour or 0.166 meter cubic per second with head about 40 meter and the pump efficiency is 84%. Now calculate the hydraulic power. According to the hydraulic power formula, we just apply the value we have and now it is divided by 1000 to convert watt to kilowatt. The water density value depends on the water temperature. I assume that the temperature is 20 Celsius degrees. So the density is 998 kg per meter cubic. And I get the hydraulic power is 65.21 kilowatt. What does that mean? The pump needs power at least 65.21 km to move water with flow rate 600 meter cubic per hour and 40 meter per head. The pump has some losses. It could be the mechanical losses perhaps. That's why the pump has efficiency. In this case, the efficiency is 84%. And if we give only 65.21 kilowatt to the pump, the output like flow rate and head will not the same as the design. In other words, the power must be higher than 65.21 kilowatt. How much should it be? We will determine that in shaft power. So the next step is calculating the shaft power. The shaft power is equal to hydraulic power divided by pump efficiency. So in this case is 65.21 kilowatt divided by 0.84 and the value is 77.63 kilowatt. The last is to determine the motor power and I have information if the motor efficiency is 90%. The motor power is equal to the shaft motor divided by the motor efficiency and the value is 86.25 kilowatt. I rounded up to 90 kilowatt. If we are already to this step, now how much electricity should we provide? In Indonesia electricity standard, the power must be higher 20% of the electric motor power. So the electricity should be provided in this case is 110 kilowatt. And the pump total efficiency can be calculated by power output divided by power input times 100%. Theoretically, the power input should be 90 kilowatt, but in practice, we should measure the power input right in the incoming side of electricity power. For example, when I measure the electric parameter such as voltage, current, and power factor, I will get the power value. Let me say the value is 95 kilowatt. The total efficiency becomes 65.21 kilowatt divided by 95 kilowatt times 100%, and the efficiency value is 68%. Okay, that's just the last explanation about the power of the water pump. I hope this video can help you to determine the electrical power needed for your system, and I say thank you for watching.